everyone, this is AP Stats Notes for 4.1. So chapter 4 is going to be about how do we collect all the data that we've been graphing and talking about so far. Where does all that information come from? And so in chapter 4, we're going to focus mostly on sampling and surveys. So the big idea behind sampling and surveys is we have this humongous population of things or people or stuff that we want to know about, but it's way too much to actually find out everything about them. It's too far spread. The group of people in it is way too big. So what we're going to do instead is we're going to take a small sample that we hope is representative of the population and use that for our numbers. And then hopefully later we'll be able to make an inference or make a judgment of maybe what that population looked like. So let's give you an example. So let's say the population is all US high school students. Okay, so if that's our population, I want to know about all US high school students, then there's no way I can go and find out and ask every single high school student. So maybe I will just take a sample of 200 US high school students instead. Now, we didn't talk about how, right? We just said, you know what, it's way too big. It's too big of a group. Let's just take a smaller sample and use that instead, okay? All right, so we've got lots of vocab here just to understand the different types of sampling methods that there are and different words that we're going to be using. But the biggest thing to think about right now is when you're talking about that smaller group that we're going to do the data analysis on, it's usually a sample, and we're using it to understand things about a bigger population. So obviously we are in the year of a census, so we're a little bit more familiar with the idea of census right now. Census is taken every 10 years, and we try to actually ask absolutely everybody in the United States, right? So we would collect data from absolutely everybody in the population. Okay, so data collected from a representative sample to make an inference about the population. That is our goal, right? Okay, so a census is not doing that. It's not taking a sample. We actually know what everything looks like, right? If I wanted to know how many pens are in the Power household, I could probably do a census of that and just go around the house and count them and have an idea of how many pens are in the Power household. If I wanted to find out how many are in all households, well, I'm not going to go and knock on everybody's door and ask to go into every room and every drawer and count all their pens. I'm going to do some sampling. Okay, so census is the idea that you absolutely collect data from every single person in the entire population. So that's the word for a census. We're going to be taking samples. Okay, so in example 1, it says, I want to know what 10-year-olds in the US think about nutrition. And the population is, so it would be all, let's see, 10-year-olds in the US, right? That's what I'm trying to find out information of, but I'm going to sample instead some smaller group. So maybe I will sample 100 US 10-year-olds instead. Okay. All right, so sample survey, choosing a sample from a large varied population. So if they ask you to do this, you want to make sure that you're relating to them, that you understand the question. You tell them what the population is, you say exactly what it is we're measuring, and then we decide how to choose the sample from the population. So let's go back to our 10-year-old idea again, 10-year-olds, okay? And we want to figure out how much sugar that they eat, okay? So we're thinking about their nutrition and their sugar intake, okay? So we would say that the population is all US 10-year-olds, right? So how are we going to measure their sugar intake? Well, the exact ins and out of it, we would do at a later point and be more detailed. And that would probably take pages and pages. But let's just say, what would we hope to put onto our graph? So maybe that would be total grams of sugar consumed in a day. Consumed in a day. Okay? So instead, I'm going to sample a smaller portion. So what's that smaller portion? I'm going to sample 100 of them, 100 US 10-year-olds. Okay, and then how we actually do it is going to be below. So there's some good ways to sample. There's some inherently bad ways to sample. There's no ultimately good and ultimately bad, but there's some that kind of lead us to believe that it's probably not going to be the wisest choice ever. So one of the ways to sample badly is to just do a convenience sample, which is exactly what it sounds like. I just take some 10-year-olds that are nearby and ask them, and they're just the most available ones, right? So what are the pros of a convenience sample? So the pros of a convenience sample is the people or the individuals are easy to reach. Right? You're making my life easy for me. I'm just going to check my neighbors and find out how many pens they have. I'm just going to ask 10-year-olds that are nearby my house. All right? The cons of this is it's probably not really representative of the entire United States 10-year-olds, right? I live in a certain area that probably has a certain influence on how much sugar somebody might eat, even within my own neighborhood. If I know that there are vegan people next door, that might influence how healthy their children eat or some other stuff like that, okay? So cons is that it's not really going to be representative. So it can actually show some biases. Okay, if it would consistently underestimate or consistently overestimate the value of what you want to know. Another way is you could do a voluntary response sample. And again, this is still under not the greatest methods in the world. So a voluntary response sample would be people themselves could answer you if they want to. So voluntary response. So I put something out on the internet and I say, hey, you know, I'm interested in how much sugar people eat. Fill out this form for me if you have a 10-year-old and tell me how much sugar they eat in a day. Okay, so the pros of this is people choose themselves. So I'll be able to get to people, right? And I'm kind of making them like part of the story, right? They get to choose that they want to be part of it. The cons of this is what types of people are going to be doing this, and are they going to be representative samples? So if parents of 10-year-olds that eat sugar, it's probably going to be people who are either super healthy when I report that their kids really don't eat a lot of sugar, or it's possibly going to be people who have an awful lot of time on their hands, and that might influence something because they could have been spending time doing other things that might have influenced the sugar intake of their child. So it's usually people with strong opinions who are going to answer this. People with strong opinions are going to be the most likely to respond, many times responding in the same direction, right? So if I put the survey out there, somebody who's just like, probably the average amount, are probably not even going to take part in my survey. Only people that are really on the extreme ends, for the most part, are going to answer that, okay? All right, so down to example 3. It says, explain a way that I could gather the daily sugar intake of 10-year-olds in the US using a convenience sample or using a voluntary response sample. Okay, so it's basically that idea that I just talked through, putting it down on paper. All right, so I'm going to go back to my blue one for convenience sample. So if I'm trying to get 100 people, I just ask 100 10-year-olds near my house. Okay, now I would think if I'm a parent and somebody in the neighborhood is asking every kid what their sugar intake is, I'm going to be a little bit suspicious of them. But they're not asking ethical questions here. They're just saying, how could I do a convenience sample? So I'd say ask 100 10-year-olds near my house. I'd just start walking around, right, and start asking people, okay? What's the problem with that? They're probably going to be geographically similar. Okay, voluntary response. Well, how do I do that? I could ask 10-year-olds to volunteer to answer my questions. So like I could put out like a survey on the internet or on Twitter or something like that, right? So a place where I think 10-year-olds might respond, or maybe the parents of 10-year-olds. So maybe a Facebook poll, right? So voluntary response sample is maybe I would ask 10-year-old parents on a Facebook poll how much sugar that they eat, right? And they just get to respond or not respond. Or I could put a question out to everyone to voluntarily respond to, but only record the first 100. Okay, so I could either just ask 100, or I could put it out to everyone, or ask everyone, and only take 100 of the responses. Okay, so both of those have inherent problems with the way that we sample them, all right? Some ways that we can sample well. So the key idea of sampling well is we want to use the idea that everybody has an equal chance to be selected, to be chosen, to be picked for a part of a survey. Everybody should have an equal chance. Okay, so a survey chosen by chance rules out favoritism from the sampler. Maybe I'm only picking cute 10-year-olds, right? Or maybe I'm only picking the slowest 10-year-olds that I can catch, right? So if I leave it up to pure chance, chance is a better indicator of making sure that I get a good mix of different things. It's not a guarantee, right? The whole thing about probability is nothing is guaranteed in probability, but it gives me the best chance, all right? So, so it rules out self-selection, and by the respondents, it rules out favoritism by me, the sampler, and we call this random sampling when we're using chance. So we call this random sampling. Involves using chance process to determine which members of the population are included in the sample. All right, so anytime that we're using that idea of chance, it's considered a random sample. Then we have one specialized name for a random sample, and that's called a simple random sample. Okay, or an SRS, simple random sample. Okay, and this one is chosen in such a way that every group of a certain number of individuals in the population has an equal chance of being selected. And you're like, how is that different? Okay, so completely random. If I put 100 people's names, or let's say I put 2,000 people's names on a piece of paper and put them into a hat, and I pick one out, they all had an equal chance, right? Until I took one out. Now it's still random, it's still an equal chance of what's left, but the probability has changed. A simple random sample really doesn't do that. A simple random sample guarantees that everybody has the same chance all the way along. So in order to do that, I would have to put the person's name back in, which would be weird, right? Because I can't pick them out twice, okay? So for the most part, for an intro level for AP Stats, they're going to use these words fairly interchangeably. If they use the word random or simple random sample, they will take either one. The idea of taking a name out of a hat, even understanding that the probability changes very, very slightly when I take one person's name out and set it aside. Or we could use something like a random number table. And a random number table are just numbers. And so I could encounter those numbers over and over again, equal chance of every number coming up. And if it's a repeat person, I just set that number aside and keep picking. Okay, so that's why we usually talk about a random number generator to pick random sample stuff. All right, so the best way to choose samples is to pick names from a hat. That's the old school way, just put everybody's name on it in a hat, mix them up, pick them out, okay? Or we could use a random number generator. Generator, also sometimes referred to as an RNG. Okay. Oh, I reversed those. So the no calculator version, this is the calculator version. Or we could use the no calculator version, and that would be just using a random number table, so something that's been printed out. So on an AP question, they're most likely to do this, is to give you a random number table so that they can have a better chance of knowing what you're likely to pick using that piece of paper. They have no idea what random numbers could show up on your calculator. Okay, so, and a hat, they can't see what you're doing for a hat either. So for AP, it's really critical that we can explain either one of these, but more likely than not, we're going to be using some kind of random number table, okay? So we want to be able to explain it. So here's the ways we explain it. If we're using technology, we want to say, give each individual population a distinct number, label them from 1 to whatever. So if we had 2,000 people in the United States, 2,000 10-year-olds, we would want to number them from 1 to 2,000. Okay, then we want to do some kind of randomization where I randomly pick 100 of those numbers between 1 and 2,000 and use them. And again, if there's any doubles, I just put them off to the side and pick out enough that I get 100 10-year-olds. Okay. If I'm going to explain how to use a table, again, I label out how I'm going to use a number of digits, which numbers apply to which students. And I'm going to try to use as few as possible. So if I think that there are 2,000 10-year-olds in the United States, which I'm sure there's more, but let's say there's 2,000, then I'm going to need 2000, at least 4 digits, right, from a random number table in order to make sure everybody gets their own digit. that means there is no number 1. They would be number 0001, right? And then the next 4 digits would be the next person, 0002, so that I have enough room for 2,000, okay? And then anybody that's over 2,000, I just throw them away, okay? So I'd want to label them first. Then I'd want to randomize, create consecutive groups of digits of the appropriate length from left to right. So I'm just going to pick them from a row that they probably give me, and I'm just going to keep picking them out in groups of 4. And every time I get a group of 4, I retrace it back to whatever I had decided to number them from. So let's say I get the number 0001, I go back to my list and I go, that's the first person from this list, that would be, and give them their name, okay? Ignore any of the group digits that wasn't used as a label or duplicates that are already picked. So anybody over 2,000, I gotta write that out. I gotta say anybody over 2,000, any numbers picked over 2,000 will be ignored. Any duplicates will be ignored. Okay, and then we tell them when to stop. Stop when we have gotten 100 10-year-old students. Okay, and your sample contains the individuals whose labels you find. So once I know those labels, I trace them back to the person's name and I write down the person's name. Okay, with a hat, very similar, right? So with a hat, I'm going to label, and this time I'm probably not going to use a number table, but I have to know how many strips of paper to put into the hat, right? So I'm going to have the same number of strips of paper. I'm going to try to make them the same size, out of the same type of paper, make them as alike as possible, fold them the same number of times, whatever that looks like. Don't over-explain that, but you get the idea. Put them into a hat and then mix up the hat so we don't get all the higher numbers first. And then we would just simply pick them out one at a time until we had the right number, and then we would list them back and put them back, okay? All right, so next one is, let's look at an example of how we would use these, okay? So they're saying use a line from table D. Now, lucky for us, they already provided table D. It's that number that says 96051, okay? And we're gonna choose an SRS of 4 hotels, follow the proper format. Okay, so the proper format looks like this. Okay, first thing I'm gonna say is who's the population, right? Who are we talking about? So this looks like we're trying to pick some hotels. Okay, so I'm gonna say the population is hotels, yeah, 20 hotels, right? That's the biggest group they're telling us to pick from, 20 hotels. Okay, they're gonna ask us to pick 4 names randomly. Okay, and then we want to tell them how. So we're going to assign numbers to those. So I will assign a unique, how many digits? I can't get away with 1, right? Not if there's 20. So I'm going to have to use 2-digit numbers, a unique 2-digit number to each hotel. And again, they've already kind of numbered it for us. So as long as I use Marriott as 01, it's still a 2-digit, right? And I will discard or ignore any duplicates or numbers that are over 20. Okay. All right, so here's my random number table. So I'm going to start going through it, and I'm going to look at them in groups of 2. So I'm going to write down, as I'm looking at them in groups of 2, what I'm deciding about each of these. So the first 2-digit number is a 6 and a 9. Lovely. And I'm going to write nothing happens with that one. Okay, then the next one is a 05. That one we're going to use, right? So we're going to pick that one. 16 is the next one. So notice I'm just breaking them up into 2-digit numbers. Even if there's a space, I'm just taking 2 digits at a time. That's one that I want. Okay, next one is 48. That's over our list of 20. Then 17, that's one of the ones I want. 87 is over. 17 again is over because I've already used 17. So I'm going to put an X next to that one. And how many am I trying to pick again? I'm trying to pick 4 names, right? Or 4 hotels. So I've got 3. I just need 1 more. The next one is 40. That's no good. The next one is 95. That's no good. The next one is another duplicate 17. That's no good. The next one is an 84. Nope. 53. Nope. 40. Nope. 64. Nope. 89. Nope. 87. Nope. And 20. Yes, there's our 4th one. All right, so I've selected the hotels that are numbered 5, 16, 17, and 20. And then I'm going to say what they are. So I'm going to say we will use 05, which is Embassy Suites, 16, which is Hampton Inn, right? And we're going to keep going from there. 17, which equals, and then 20, which equals. Okay. So that's how we do sampling with a random number table. That's likely to be the one most likely to be seen on the AP exam. All right. All right, next one. Let's do some advanced sampling techniques that we can talk about. It says take an SRS from the population and use your sample results to gain information about the population. So here are some advanced sampling techniques. The big two that we're going to talk about today is going to be stratified and cluster sampling. These are the ones that people most often confuse for each other. So let's talk about what a stratified random sample is. It is no longer a simple random sample. We're going to do something else to it. Okay, so what we're going to first do is we're going to start by classifying the population into groups of similar individuals. So like if this was a football example, we would be breaking them out and my strata would be all the different teams, right? Somehow or another, whatever I'm measuring, I think might be different across the different football teams. So those are my strata, is I want to make sure I have a group from one team, a group from the next team, a group from the next team. So it's usually a demographic like an age, a gender. Those are called stratas, okay? And there's usually somewhere around 6 or less stratas that we're talking about. Sometimes it's just 2. It's just like male or female or something else that they can do that's super simple. That's just binary, less than 50, more than 50, something years old, something like that. Okay, so we're gonna choose a separate SRS from each stratum and combine these SRS to form our sample. So then what it looks like is I wanna make sure that I sample from each one of those football teams, and I'm going to sample an equal number from each one of those football teams to get a good representative sample of all the football players from all the football teams. Okay, so that's no longer just random chance, right? Because random chance could have had everybody accidentally be selected all from the same team. So I'm messing with random chance a little bit, but I have a good reason to, right? Because I want to make sure I get somebody from every team represented. So it seems like it's a good reason to do it. So this is not under the bad ideas. This has a purpose. If I want to make sure that I get somebody from each one of those football teams, then I have to make sure I pick them from each one of those different teams, and those are called strata or a stratified random sample. Then when I take each one of the football teams, let's say the Cleveland Browns, then I can number all of those members in the Cleveland Browns from 1 to whatever, and then I can randomly sample a certain number to get my team numbers for my samples. Then I go to the next team, number them, do the same thing to pick a random sample, combine them into my group, okay? So samples must have an equal selection from each group that is proportionate to the population. So if there was any rule that like didn't say that teams couldn't be a certain size, like let's say that for some reason the Chargers were allowed to have twice as many, well, then maybe we'd pick twice as many from the Chargers to be a representative proportion of the population of all football players. Okay, so if we know they're about equal sizes, we take about an equal amount from each one. But if we know one is significantly more than the other, then we want to pick significantly more from that strata than from others. Okay, no individual can belong to more than one group. They have to be within one of those groups. Okay, so random selection, but we do the stratified first. Okay, that's often done when we're trying to make sure that we get certain categories of people, like maybe there's something that's a race, and I know that there's a minority race, and I want to make sure that I get them into my sample because I want to hear what they were going to say. But if I leave it to chance, I might not get them at all, or I might get them at a greater proportion than what they are in the population. So it's a way to manage the numbers to make sure that I'm getting about the right number that kind of reflects the population. But it's no longer allowed to be called a simple random sample. It's a stratified random sample, okay? All right, so that's the idea for a stratified random sample. Okay, so let's see, what else? Example 4, explain how you gather a sample of 100 high school students from the following that represents 2,000 high schools. Okay, so let's say that we know that 60% of those schools are suburban, like us, 20% are inner city schools, 10% are out in the country, or 10% are out in the country, and 10% are other that can't be defined those ways. So now we have the stratas are different types of schools, right? And I'm trying to pick 100. Well, based on strata, I need to make sure that I pick 60 from the suburban school, 20 from the urban school, 10 from the rural school, 10 from others, so that I get a sample of 100, but that they're equally represented. Okay, so it says choose a blank of blank from the suburban school. So I think what they're looking for me to say is choose an SRS of 60 from the suburban schools. Now remember, the suburban schools is one of the stratas. Okay, so once I have them grouped out, then I take a simple random sample from them. Okay, the second one is we're going to choose an SRS of 20 from the urban schools. That's our second strata, and we're going to just keep going. Choose 10% or choose an SRS of 10 from the rural schools, and then choose one final SRS of 10 from the other schools. Okay, so in here the stratas are the types of high schools, okay, and their locations. All right, cluster sampling. Okay, in cluster sampling, it's usually done because I have no idea how many people I'm dealing with. Okay, it's usually so big that there's no way I could number them and do a simple random sample or pick their names out of the hat. There's just too many. So instead what we do is we basically just say, I'm going to take a scoop, and I think that scoop is going to be different enough that it's going to represent the population. So we're taking a smaller bit, but we're trying to take a smaller bit that we think is representative of the entire population. So that might be something like a zip code, right? Where I might say, you know, I can't sample everybody in California, but I could take a few samples or a couple scoops from random zip codes, and then I could figure out those and say that those are representative. Okay, now I'm not going to do it from every zip code because then we're back to census again. So I am going to do a random sample of the zip codes, and those zip codes are clusters because we're thinking that they're all different within those zip codes. The other key thing I'm going to do is I'm going to take a census of everybody within the cluster. So in a stratified, we decided we were going to use teams, like football teams, and I was only going to pick a few players from each one of the football teams. In a cluster, once I pick a zip code randomly out of a hat, everybody in that zip code is going to be asked, is going to be part of that sample. Okay, so that's the big differences there. In strata, we divide them out first because we find unique characteristics of them and then do an SRS. In cluster, we try to figure out how to break them out where we think we're going to get a representative mixed sample. Then we take an SRS of those, and then we ask everybody in that group. Okay. All right. So, and we're hoping that the clusters are close to the same size as possible. All right. So explain how you would gather a sample of 4 clusters of Los Angeles County residents where groups are separated by zip code. So this is exactly that idea of how do we do that. Okay, so we would say the clusters are the separate zip codes. Okay, and we're doing this because we think each zip code is a representative sample of all of Los Angeles. Now we know that that's not technically true, right? If we pick a zip code up here in Santa Clarita, it's not going to look the same as a zip code that's in inner city LA, but you get the general idea. So this is leaning towards not the greatest method to do because we're lazy. We just don't want to count. There's too many, right? So we just go, we'll just count less. Okay, so the clusters are the separate zip codes. So then I'd have to say how I'm going to do that. So I'm going to list all the zip codes. List all the zip codes. And then I would list all the zip codes with a number. Use a random number generator to pick 4 numbers. And then those 4 zip codes, those 4 zip codes, ask all residents within those 4 zip codes. Okay, so you can see how challenging this would be. Even if we believe that they were equal representative samples, how do I get to everybody within a zip code, right? We know that there's going to be problems with those. People are going to move in before I finish counting, move out before I finish counting, be homeless, be transient. Like there's so many other issues. So we're just going for the main ideas here. Okay, so what's the pro of a cluster? Well, it's really about money. It's easier to do. Okay, so the population, so what do we say for the cluster? It reduces the cost. I don't have to go into every zip code. I just have to go into 4 of them. So it's a reduced cost. So it's usually cheaper. Okay, because they're usually all within a cluster, so I just have to do them. The cons is that it's going to be less precise than an SRS or even stratified. Stratified. And that's simply because of that idea that it's going to be really, really difficult to get zip codes that are truly going to be a good mix of everybody in Los Angeles County. Okay, so why do we do this random stuff, right? Part of it is that it avoids bias of who I'm picking. I'm not just picking the people I like or the people who are smiling at me and seem ready to answer a survey for me, right? By doing that randomly, it takes out any of those type of biases or any type of preference that I might even unconsciously have. And the laws of probability allow trustworthy inference about the population. Basically, if we're using probability, we're saying anything could happen, likely to happen. We're just going to let chance take its toll on the results. Okay, so results from random samples come with a margin of error that sets the boundaries on the size of the likely error. So usually you will say that I believe these answers are correct within plus or minus this many %, and that's usually based on how well you think this one actually selected things. We're not going to go into margin of errors yet. We will do it later, but for now, just the idea that that every time we pick a random sample, there's usually some kind of error involved with it. So the larger the sample I do, the better I'm going to have input on what the population truly looks like than if I just pick smaller samples, right? So if I just pick 1 zip code, that's not as good if I pick 10, right? And if I could pick 10 and you give me a choice to pick 100 because there's 1,000, that's going to be more. Again, I'm balancing the cost. So at some point, I'm going to make that decision on this is the number I can live with. Okay, so good sampling techniques reduce sources of error. So there's all kinds of error or biases. Okay, so we're going to go through a few of these, and I've already pre-printed these in for you. Okay, a lot of these overlap. So a lot of these have words that kind of describe more than one. So the main idea of undercoverage is that some members don't even get to be chosen. They can't be chosen. So let's say that you called somebody's house and you're figuring you're going to do all residents of a town. Well, if you call a house, there might be more than one resident there. How are you ever going to get the person who didn't answer the phone, right? So there's going to be undercoverage there. I'm only going to get the one who answers the phone. Okay, non-response. Individuals chosen cannot be contacted or they refuse to answer. So the person chooses not to respond. Okay, so maybe you call them and they hang up the phone. Well, that's non-response, right? So they moved maybe, their phone number is no longer in use, they died, right? Whatever reason, they're just angry and they just don't want to participate, okay? Response bias. It's a pattern of incorrect responses in a sample survey. So a response bias is anything that skews the results coming back to you. So it could be that it's just a person who answers incorrectly on purpose. Why would they do that? Well, maybe they want to be perceived a certain way. Like if I ask how many hours you spend watching TV or on your computer or on your phone in front of your parents, that might be a different answer than if I asked it on paper where nobody else is hearing the answer, right? If I asked how much do you exercise a day, that answer might be different if somebody is listening to your answer or seeing your answer. So that's a response bias. The person who's answering chooses to kind of lie to make themselves look better or they think to look normal, okay? Also, response bias, sometimes it's just who decides to respond to a random survey. So that idea of strong opinions are the ones who respond, either strongly for something or strongly against something. Often these are political type polls where if they're voluntary, call into the show to give your opinions, you're going to hear extreme versions on one side or the other. And then lastly, often wording of the questions can make a difference in what we get and whether it's truly a good sample or not. So how you word the question. There are times where you can lead a question a certain way to encourage somebody to give you a response back. For example, if I say, how many days a week do you drink milk? It's already inferring that you drink it. So I'm already asking like you do versus do you drink milk? Yes or no? That seems equally pretty balanced, right? Or did you know that apple juice can improve skin tone? I don't know, I'm making it up, right? Do you drink apple juice? Well, now I've given you kind of leading information and kind of pushing you towards a certain answer. So sometimes the wording of the questions can influence the answers given, or even the options if you give them multiple choice and there's other options that aren't on there. That might be a wording of a question or some kind of bias as well. So like I said, there's a lot of overlap here. Think about it in generic terms of what the real definition is. All right. So that's where we're going to stop for today. We'll see you next time.